Have you ever wondered what lies beyond our planet? Voyager just gave us a glimpse into the unknown, and the results are unsettling. Could this be the key to unlocking new frontiers in our galaxy? The Voyager probes, launched in 1977, were an audacious mission for their time. Designed to explore the outer planets, these spacecraft were humanity's first real attempt to push beyond our local cosmic neighborhood. Voyager 1 and Voyager 2 both exceeded their original missions, becoming our most distant ambassadors. Think of it this way. These probes weren't just groundbreaking because they left Earth's orbit. They were designed specifically to travel farther than any other machine we've ever created. And they succeeded. These two tiny ships, roughly the size of a subcompact car, now operate in the impressive nothingness of interstellar space. Regions so uncharted, they're almost as mysterious today as they were when the probes first launched. Deep space itself is difficult to grasp because of its sheer scale and its emptiness. For a tech enthusiast, it's almost frustratingly poetic. Imagine designing a device that works reliably in conditions where there's no atmosphere, virtually no heat, and everything around it is billions of miles apart. Voyager's travel through this realm is a testament to how far technology and human ingenuity could go in the 1970s. These probes were equipped to act as scientists in their own right, collecting data from the farthest corners of the solar system and beyond. For instance, they've relayed information on phenomena most of us never think about, like solar wind or the heliosphere, the sun's protective bubble of charged particles.
What's even more fascinating is how Voyager gathers and sends data.
Back then, it carried instruments like magnetic field detectors, plasma wave sensors, and cosmic ray counters. These were cutting-edge tools for detecting things that can't be observed on Earth. Now, in interstellar space, Voyager communicates with us using the Deep Space Network, sending faint radio signals back to Earth. Think about how impressive that is. A spacecraft more than 14 billion miles away, still getting messages through ancient onboard technology and Earth-based receivers. Decades after their launch, they remain operational, though much of their energy is now focused on their most critical instruments. Voyager was expected to help us understand radiation patterns, magnetic fields, and even planetary atmospheres. Scientists theorized it might detect gravitational waves faintly passing through the galaxy, or cosmic radiation from unexplored regions of space. It was like sending a fishing net into the deepest ocean, with hopes of finding something rare, but still grounded in probabilities. For years, its discoveries added to the puzzle of space science, but nothing broke the mold of what experts thought they'd find. That is, until now. Recently, Voyager returned data unlike anything it had recorded before. It isn't a planet, a comet, or even a fleeting particle wave. What's caught the attention of the scientific community is an anomaly, something the probe detected that doesn't fit the usual categories of cosmic phenomena. The data doesn't follow expected patterns or match any predictions. And this is where things get really puzzling. Traditional models of space behavior can't explain it. Remember, Voyager was built to spot things like high-energy particles or shifts in magnetic fields. Yet this result, whatever it is, doesn't seem to resemble any of those.
Picture it like this. In a vast, empty void that stretches for light years without end, where the signals of stars and planets are faint and distant, this anomaly stands out.
It's as if through the static of billions of years, Voyager tuned into a whisper that no one expected. And that's thrilling and disconcerting, because it suggests there's more out there than we have the tools to comprehend.
One potential theory is that the signal could represent an entirely new kind of cosmic structure. It could mean that the universe isn't shaped the way we think, or even governed by all the same rules we've identified so far. Just imagine how revolutionary it would be for cosmology if this anomaly pointed the way to understanding dark matter, dark energy, or something else entirely unclassified.
The discovery might not just be important. It could be the beginning of a paradigm shift for how we view reality itself. And while scientists are working hard to identify and decode the data entirely, the broader significance is already clear.
Voyager didn't just deliver a lonely blip on the radar. It may have just handed us the next great mystery of the cosmos. But what could it mean for humanity's future understanding of the universe?
we are about to explore the most intriguing theories, ones that range from natural causes to something even more extraordinary.
Could this be evidence of something entirely new, or even artificial? That's the big question facing scientists as they try to untangle the mystery behind the anomaly detected by Voyager. Naturally, the first place experts start is with what they already know. One of the leading theories involves pulsars, those rapidly spinning neutron stars that emit beams of electromagnetic radiation like cosmic lighthouses. Since pulsar emissions can appear as repetitive and structured signals, they've often been mistaken for something unusual. But here's the issue. The data Voyager sent back doesn't match the consistent, rhythmic patterns typical of a pulsar. So, while it's worth investigating, the pulsar explanation doesn't completely hold up. Another possibility involves interstellar magnetic fields. Voyager is still passing through a part of space influenced by the galaxy's magnetic environment. Scientists know that disturbances in magnetic fields can create unique electromagnetic signatures that could, at first glance, seem strange. But again, the problem is how this anomaly doesn't seem to behave like anything we've seen from magnetic field interactions. What's more, the signal seems too isolated, too distinct from the usual interference that comes with these phenomena. This is where alternative ideas start gaining ground. Some researchers have suggested the anomaly might involve dark matter. Since dark matter doesn't emit light or energy the way normal matter does, it's notoriously difficult to study. But if Voyager happened to pick up on a rare interaction involving dark matter particles, it could explain why this data feels so unprecedented. Others speculate it might involve an unknown energy source, something outside the categories of radiation or particles we currently understand. It's a reminder that the universe could host forces or interactions that our best instruments aren't yet designed to fully capture or even identify.
Now here's where the theories get especially intriguing. What if the signal isn't natural at all? Could it be evidence of advanced technology? While this idea is often reserved for science fiction or dismissed outright, there's always a slim chance that we might stumble upon something artificial. The idea here isn't necessarily alien life forms broadcasting a message, but perhaps technology left behind by an advanced civilization. Think of it like discovering a decades-old satellite orbiting Earth, except on an interstellar scale. If Voyager happened to pick up a signal or artifact of technology that's not of human origin, it would rewrite everything we think we know about the universe. This anomaly reminds us how much we still don't know about the universe. Every strange signal or unexplained reading holds the potential to reshape the way we see existence itself. Whether it's a rare quirk of physics, a new cosmic phenomenon, or even something artificial, it's a powerful reminder of how small we are in the grand scale of things, and how much there is still left to discover. What do you think this anomaly could be?
Share your thoughts in the comments below, and don't forget to subscribe for more updates on space exploration and the mysteries of the cosmos.
Thanks for watching. See you in the next one.